Good morning, friends. My name is Yashwant Gowda SR. I am studying in Sri Venkateswara Engineering College. Today we will discuss about the topic the multiplicative group of integers modulo p. Welcome to our journey into the fascinating world of abstract algebra, especially focusing on the multiplicative group of integers modulo p. The presentation will be cover the fundamental concepts of modular arithmetic and group theory, leading us. Let's understand the properties and applications of ZP and a cornerstone in a modern cryptography and a number theory. Defining the multiplicative group of integers modulo p ZP star. The multiplicative group of integers modulo p denoted as ZP star consists of the set of integers 1, 2, p to n. Under the operation of a multiplication, let's understand the modulo p, where p is a prime number. It's a fundamental concept in abstract algebra, forming the basis of many cryptographic algorithms. This group is specially defined for prime moduli, because prime numbers guarantee them every non-zero element as a multiplicative inverse, which is a crucial property for a group. Understanding ZP star requires a grasp and a modular arithmetic, where numbers wrap around upon reaching a certain value. The modulus, for example, in modulo 5, 3 into 4 is called around 12, which is 2, and modulo 5. The seeming simple structures holds profound mathematical significance. Set definition: ZP star is equals to 1, 2, p to 1. Operation multiplication of modulo p and modulus conditions. Properties of ZP star are closure, associativity, and identity and inverse. For a set with an operations to be considered a group, it must satisfy an axioms: closure, associativity, existence of an identity element, the existence of an inverse for every element. ZP star perfectly fulfills these requirements. Closure ensures the multiplying any two elements within the set results in another element within a set. Associativity means that grouping of operations doesn't affect the result. The entity element is one, as any number multiplied by one remains itself. Crucially because p is a prime, and every element in A is ZP star, which can be inverse B, such that A into B is equals to 1, a cyclic group. Closure for all A, B is belongs to ZP star, and A into B modulus of P, which belongs to ZP star. Associativity for all A, B, C belongs to ZP star, where A into B into C modulus of P, and A into B and B into C modulo P. Identity: there exists an element 1 belongs to ZP star, such that for all A belongs to ZP star, A into 1 and into 1 modulo P is equals to A inverse. For each A belongs to ZP star. Exploring the primitivity roots modulo P. A primitive root modulo P is an integer G, such that every integer in ZP star can be expressed as a power of G modulo P. In simple terms, G generates all the elements of the group ZP star. This property is incredibly important, as it gives ZP star a cyclic group, and meaning the group can be generated by a single element. Not all numbers can be primitive roots. For a number G to be primitive root, modulo P, its order must be equal to almost P minus 1. The existence of primitive roots is guaranteed by prime numbers, making them a crucial aspect of ZP star, and its aspect of ZP star and its applications in number theory and cryptography. Definition generates all elements of ZP star. Order of G uh, is equal to P minus 1. Significance underpins a cyclic group structure. Examples of ZP star for small prime numbers. Let's illustrate a ZP star with some small prime numbers to solidify our understanding. These examples demonstrate how the elements behave under multiplicative modulo P and how the group properties hold true. For Z5 star, the elements are 1, 2, 3, 4. Let's take G is equals to 2, the power of modulo powers of 2 modulo 5. Since 2 generates elements, 2 is a primitive root. The systematic exploration helps in understanding the structure and cyclic nature of these groups. where you can see the Z3 star and Z5 star and Z7 star. Applications of cryptography define Hellman key exchange. One of the most impactful applications of ZP star is in cryptography, particularly in Diffie-Hellman key exchange protocol. The protocol allows two parties to establish a shared secret key over an instance communication channel without every directly exchange the key itself. The security of the Hellman release on the computational difficulty of the discrete logarithm problems in the ZP star. While it's easy to perform a modular exploitation, it's incredible hard to reverse the process of find B and A, comma A power B in modulo P. The asymmetric makes ZP star an ideal foundation for secure communication protocols like TLS and SSL, which protect our online transaction and data. Public parameters, where you can see at least an example, and even in private keys, you can see an example. And in the public keys, Alice computed A is equals to G power A and modulo P. And shared secret, Alice computed K is equals to B power A and modulo P. Practical computation and algorithms in ZP star. Working with the ZP star, practical applications often involves efficient algorithm for modular finding inverse and generating primitive roots. While calculations for small primes are straightforward, real-world cryptography applications use extremely large prime numbers, making brute force methods infeasible. Algorithms like square and multiply method significantly speed up modular exploitation, reducing the number of multiplications and multiplications required. The extended Euclidean algorithm is used to efficiently commutate modular inverse for finding a primitive roots. Their primitive roots, there isn't a simple formula. Instead, algorithms rely on checking the order of elements based on the primary factorization of p minus 1 and factorization of p minus 1, where you can see a modular exploitation and model inverse and primitive root sets. Summary, key takeaways, and further exploration. We traversed the landscape of the multiplicative group of integers modulo p, from its basic definition and group of properties to its profound applications. The model cryptography ZP star is more than an abstract mathematical concept. It's a foundational element enabling secure digital communication and protecting sensitive data worldwide. The beauty of ZP star lies in the cyclic nature driven by the primitive roots, where you can see a group theory foundation and primitive roots and cryptography. Thank you.